Search Google Images for a golden retriever running on a beach at sunset. The system isn't looking for exact words. It searches by meaning. This is a massive departure from how traditional databases like MySQL or PostgreSQL operate. Those systems are built for structured data, names, dates, and prices. They rely on exact keyword matches. If you ask for customers in Oman, they find that specific text string and return the result. But if you ask it to find frustrated customer reviews, and the reviews use words like annoyed or disappointed instead of frustrated, the system will find nothing. It has no concept of emotion or context. Because these systems are restricted to rigid categories and exact matches, they remain blind to the nuanced ways humans actually communicate and think. Modern large language models like GPT-4 represent a shift from searching to generating. These are deep learning engines designed to understand the intent behind a prompt, rather than just the keywords. However, these models have a strict operational boundary called a context window. Think of it as a very short-term working memory. Once that window is full, the model begins to forget the start of the conversation, effectively suffering from permanent amnesia. This limitation means an AI cannot inherently remember your company's internal handbooks, your private project files, or thousands of pages of real-time market data. For AI to be useful in a professional setting, it needs a way to bypass this bottleneck. It requires an external, instantly searchable long-term memory. When an AI reads a sentence, an embedding model translates the text into a list of numbers called a vector. Sentences with similar meanings produce vectors mathematically close in 3D space. An opposite sentence generates a vector pushed far away. A vector database is a specialized system built to store and search through billions of these numerical points. Instead of looking for an exact text match, it performs an approximate nearest neighbor search, finding the data points physically closest to your query. To handle this at scale, the database uses indexing algorithms like HNSW to organize the points into regions. This allows the system to skip the majority of the data and find a relevant match among a billion vectors in under 100 milliseconds. By turning human meaning into spatial coordinates, we give machines the ability to calculate the similarity between massive amounts of unstructured information. Raw company data passes through an embedding model, creating vectors stored in the database. A user's question is also vectorized. The database finds the closest matching documents and hands them to the AI to generate an accurate answer. This is Retrieval Augmented Generation, or RAG. RAG allows an AI to recall specific, proprietary facts without the massive time and expense required to retrain the core model. This mathematical retrieval process is already the hidden engine for your daily habits. When Spotify or Netflix recommends a new song or movie, they are using vectors to find content that exists in the same mathematical neighborhood as the things you already enjoy. In the enterprise, this same technology allows banks to spot fraud by identifying transactions that look similar to known theft patterns, and helps medical researchers find similar patient records across millions of files. As AI becomes multimodal, the role of these databases will grow. They provide a single, universal language where text, images, video, and audio can all be compared and retrieved using the same coordinate system. Vector databases provide the specialized architecture that links an AI model to a persistent, searchable memory. They serve as the neural backbone that allows these systems to organize, recall, and utilize the vast scale of human data.